Welcome to Computics Technologies.
A database is a structured collection of data that is organized, stored, and managed in a way that allows for efficient retrieval and manipulation of information. It serves as a central repository for various types of data, such as text, numbers, images, videos, and more. Databases are commonly used in various applications ranging from small scale personal projects to large enterprise level systems. There are so many types of databases like relational databases, NoSQL databases, graph databases, time series databases, etc. Databases helps you organize the data. It helps you in integrity of data, in security of data, scalability, and in recovering and backup the data even if it's lost. In short, databases play a pivotal role in modern day information management, providing numerous benefits and serving as a critical infrastructure for various applications. Databases are indispensable tools that empower businesses and individuals to store, manage, and analyze data effectively, driving innovation and enabling informed decision making across various industries. A relational database is a type of database that stores and organizes data in a tabular format using rows and columns to represent different entities and their attributes. In a relational database, data is structured into tables where each table represents a specific entity and each row in the table corresponds to a specific instance of that entity. The columns in the table represents the attributes or properties of the entity. Database management systems are software systems used to store, retrieve, and run queries on data. Database management system manage the data, the database engine, and the database schema, allowing for data to be manipulated or extracted by users and other programs. This helps provide data security, data integrity, concurrency, and unified data administration procedures. Relational databases are widely used for various applications and are known for their flexibility, scalability, and ease of use. They are employed in a wide range of industries and applications, including business data management, customer relationship management systems, financial systems, and much more. Some popular examples of relational database management systems include MySQL, PostgreSQL, Oracle, Microsoft SQL, SQLite, and MS Access. So far, we come to learn what is a database and relational database. This chapter of relational database concept is one very important part of this entire video. Now we will learn the concept of tables, rows, and columns, and concept of primary and foreign keys. Concept of relationship and normalization in databases. In relational database, data is organized into tables, also known as relations. Each table represents a specific entity, and each row in the table represents an individual record or instance of that entity. Rows are also referred to as tuples. Each row in a table contains data related to a single entity or record. Columns are known as attributes or fields. Each column in a table represents a specific piece of information associated with entities. As you can see in this example, data is well organized in a table, and rows storing the details of student and columns storing the student ID, name, age, and gender of the student. A primary key is a unique identifier for each row in a table. It ensures that each record can be uniquely identified and differ it from other records in the table. As in the table,
we use earlier student ID is the primary key because it has different value in every column. Values of primary keys are always different. They cannot be repetitive. As in this table, students can have same name or age or even gender, but the ID given to them will always be unique. To understand this better, let's take an example of an ID card number of a person which is always unique and different from others. A foreign key is a column or a set of columns in a table that establishes a link between two tables. It refers to the primary key of another table, creating a relationship between the two tables. In this example, student ID serves as the primary key in the students table as we learned earlier and uniquely identifies each student. In the courses table, course ID is the primary key and student ID, which is the primary key of students table, is used as a foreign key to establish a link between a student and the courses they are enrolled in. In short, primary key of one table will be work as a foreign key when it is used in another table.
Now the next concept is relationships. Little bit of complex, but don't worry, we will make short work of it. What are relationship in database? Relationships are association between two tables. A relational database collects different types of datasets that use tables, records, and columns. It is used to create a well-defined relationship between database tables so that relational databases can be easily stored. There are three different types of relationships in a relational database. One-to-one relationship. It is used to create a relationship between two tables in which a single row of the first table can only be related to one and only one records of the second table. Similarly, the row of a second table can also be related to any one row or record of the first table. This relationship is relatively rare in databases and often used to break down a large table into smaller, more manageable pieces. Let's understand this with an example. There is a table named teacher which is storing teacher's data. With the teacher ID will work as primary key in this table. And now suppose there is another table of subjects which is storing different subjects. Teacher ID is primary key of teacher's table, but in the subjects table, teacher ID is used as foreign key to create a relationship between two tables. If you see teacher with teacher ID 201 is only described once in the subjects table, so it means the teacher will only be teaching that only one subject in which row it is defined. In our case, it's mathematics, as teacher ID 201 is not defined twice and all other teacher IDs are also defined once against only one record of the subject table. It means a teacher can only teach one subject or only one subject can be taught by only one teacher. One to many or many to one relationship. In a one to many relationship, a single record can be associated with multiple records in another table. However, a record in the second table can only be related to one record in the first table. This is the most common type of relationship. Let's take the earlier example of teachers and subjects table. But in this example, you can see teacher ID 201 is defined multiple times, but only against different subjects. It means a teacher can teach multiple subjects, but a single subject can only be taught by one teacher. As in this case, teacher with teacher ID 201 can teach math and English, but math and English can be taught by only 201
they cannot be taught by any other teacher. Many to many relationships. In a many to many relationship, multiple records in one table can be associated with multiple records in another table. For example, there are two tables of employees and projects. In this example, each project can involve more than one employee and each employee can be working on more than one project. Normalization. Normalization in DBMS is a technique using which you can organize the data in the database table so that there is less repetition of data. A large set of data is structured into a bunch of smaller tables, and the tables have a proper relationship between them. There are three forms of normalization in database. First normal form 1NF. The basic rule of 1NF is that each cell in a table must contain a single value, meaning there should be no repeating value. Additionally, each table should have a primary key that uniquely identifies each row. Second normal form 2NF. For a table to be in 2NF, it must meet the requirements of 1NF and additionally ensure that all non-key attributes are fully dependent on the entire primary key. In other words, records should not depend on anything other than a table's primary key. Third normal form. To achieve 3NF, a table must meet the conditions of 2NF and eliminate fields that don't depend on the key. Values in a record that aren't part of that record's key don't belong in the table. In summary, normalization helps eliminate data anomalies and improves database efficiency by reducing repetition of data. However, achieving higher normal forms may result in more complex query structures and joins, so the appropriate level of normalization depends on the specific needs of the application and database's performance requirements. SQL stands for Structured Query Language, is a database language designed for managing data held in a relational database management system. It provides a standardized way to interact with databases, allowing users to create, retrieve, update, and delete data. Select. The select command is used to retrieve data from a database. It allows you to specify the columns you want to fetch and apply various filtering conditions to narrow down the result set. The basic syntax of select is this: select name of columns from name of table where and the condition. Insert. The insert command is used to add new records to a table. It allows you to specify the values for each column while adding a new record. The basic syntax of insert statement is insert into name of table in brackets columns names and values in brackets give away the values. Update. The update command is used to modify existing records in a table. It allows you to change the values of specific columns in one or more rows that meet certain conditions. The basic syntax of update statement is update name of table set column 1 and then is equal to value, column 2 is equal to value, and so on, where condition. Delete. The delete command is used to remove one or more rows from a table based on specific conditions. The basic syntax of the delete statement is delete from table name where condition. Database design is a crucial step in creating an organized and efficient data storage system. An entity relationship diagram is a type of flowchart that
tells us that how entities such as people, objects, or concepts relate to each other within a system. ER diagrams are most often used to design or debug relational databases in the fields of software engineering, business information systems, education, and research. Also known as ERDs or ER models, they use a defined set of symbols such as rectangles, diamonds, ovals, and connecting lines to describe the entities, relationships, and their attributes. Now the next thing is how do you plan and database schema? Well, it is easy. There are 5 different steps to plan a database schema. Number 1. Identify entities. These could be objects, concepts, or events that you need to store information about. Number 2. Define attributes. For each entity, define the attributes that will store relevant data. Number 3. Determine relationships. Establish relationships between entities. Relationships can be one to one, one to many, or many to many. Number 4. Normalize data. Organize the data to minimize repeatancy of data and ensure data integrity. Number 5. Primary and foreign keys. Identify primary keys for each entity and foreign keys to establish relationships between tables. Data integrity is a critical aspect of database management, ensuring that data remains accurate, consistent, and reliable throughout its life cycle. Constraints are rules or conditions applied to database tables to enforce data integrity by specifying what values are allowed or disallowed in certain columns. Not null constraint. The not null constraint ensures that a column cannot have a null value. This constraint is used to enforce the presence of a value in a specific column. It guarantees that every row in the table will have a valid value in that column. Now assume that we have the simple create table statement that is used to define the constraint demo1 table. This table contains only one column with the name of ID. In the ID column definition statement, the not null constraint is enforced, considering the ID column as a mandatory column that should be provided with a valid SQL not null value. Unique constraint. The unique constraint ensures that the values in a specified column are unique across all the rows in the table. This prevents duplicate entries in the specified columns, maintaining data accuracy and consistency. Let us create a small table with 2 columns, ID and name. The ID column cannot hold duplicate values due to unique constraint specified with the column definition. No restriction defined on the name column as in the create table statement. Check constraint. The check constraint allows you to define a condition that must be satisfied for the values entered in a column. This condition can be based on logical expressions, comparisons, or functions. It helps ensure that only valid data is inserted into the column, adhering to specific rules or conditions. The above query will restrict the s underscore id value to be greater than 0. So the check constraint is used to apply conditions in database tables. Default constraint. The default constraint specifies a value that is automatically assigned to a column when no explicit value is provided during an insert operation. This ensures that a predefined value is used when a new row is added without explicitly specifying a value for that column. In this example, the statement sets the hire date to the current date if not specified manually. By using these constraints, you can maintain data integrity and help prevent inconsistencies or errors in your database. Transactions. A transaction in the context of databases refers to a sequence of one or more operations that are treated as a single unit of work. These operations can involve reading, writing, or modifying data within a database. The primary goal of using transactions is to ensure data integrity and consistency even in presence of failures. Applying the ACID properties determines whether a transaction should be committed or rolled back given the success or failure of each step in the transaction. If a transaction does not adhere to these properties, the integrity and reliability of the data can be called into question. For example, if the transfer transaction had failed after deducting the $200 from the savings account, but before adding the funds to the checking account, a customer's accounts would be short $200. But what are the ACID properties? ACID is an acronym that stands for atomicity, consistency, isolation, and durability. These properties are essential to maintain the reliability and integrity of transactions within a database system. The system will typically apply these four properties to those transactions for ACID compliance. Atomicity. This property ensures that a transaction is treated as a single, indivisible unit of work. Either all the operations within the transaction are completed successfully or none of them are applied. If any part of the transaction fails, the entire transaction is rolled back to its previous state and no changes are made to the database. This property helps in maintaining data integrity and prevents incomplete or inconsistent data changes. Consistency. A transaction must preserve the consistency of the underlying data. The transaction should make no changes that violate the rules or constraints placed on the data. For instance, a database that supports banking transactions might include a rule stating that a customer's account balance can never be a negative number. If a transaction attempts to withdraw more money from an account than what is available, a transaction will fail and any changes made to the data will roll back. Isolation. A transaction is isolated from all other transactions. Transactions can run concurrently only if they don't interfere with each other. Returning to the transfer transaction example, if another transaction were to attempt to withdraw funds from the same savings account, isolation would prevent the second transaction from the firing. Without isolation, it might be possible for the second transaction to withdraw more funds than are available in the account after the first transaction was completed. Durability. A transaction that is committed is guaranteed to remain committed, that is, all changes are made permanent and will not be lost if an event such as a power failure should occur. This typically means persisting the changes to non volatile storage. If durability were not guaranteed, it would be possible for some or all changes to be lost, affecting the data's reliability. In summary, systems that support transaction processing employ various methods to ensure that each transaction is ACID compliant. For example, SQL Server includes integrity constraints such as primary key, foreign key, unique, and check to achieve data consistency. The system also supports isolation levels such as read committed, read uncommitted, and snapshot to provide the necessary isolation for each transaction. These features are built into the database system so they can be included easily into an application's backend database, although they need to be carefully implemented to ensure maximum ACID compliance.